So the last piece of this little moron hypothesis testing is to start thinking about the significance level and statistical significance and what all that means. So our significance level is this threshold that we set in advance for determining what a rare event is. We'll eventually find out that when we set our significance level, we're also setting our acceptable amount of type 1 error. But for now, just think of it as this threshold for something being unusual enough that we can say something is up and we can reject the null. But there are certain situations where you have a set p-value or set alpha that you have to meet, and that would be like clinical trials. Like that would be a set alpha where the FDA probably has an alpha of 0.01 or 1% that you have to meet in order to be able to show that your drug is statistically significant. But most of the time, we don't have such a set in stone alpha level. So especially if you're thinking about like your projects moving forward, if you get out a p-value of 0.0511, well, most of the time we compare this to our most common alpha level of 0.05. And in this case, that value is just slightly bigger, so we'd fail to reject the null. But that means that you're saying there is not enough evidence to prove whatever it is you're trying to prove. And that's disappointing, right? Especially, you have to imagine, a lot of times people spend a lot of time working on research to then get out something that is so close to being significant. So what you would probably do in this case is you change and you just say at a 10% significance level, there is enough evidence, blah, 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 blah. So unless you're in a situation where you have to have a certain alpha, or a question where I've given you an alpha, if you're doing something like a project, you should look at the different alphas that you have available to you, 1%, 5%, and 10% being the most common, and basically choose the best one that you can get and reject them all. All right. And then the last piece here, practical versus statistical significance. If you have a large enough sample size, you can actually buy yourself statistical significance. And so what that means is that you could end up with p-values that are very impressive for differences that really aren't very meaningful. So there's a very silly example here. But suppose a diet program has a 1 ounce weight loss per week that is statistically significant with a p-value of 0.001. So these people could definitely report out that this weight loss program is guaranteed to help you lose weight, statistically proven, and report out just their p-value. But what you really want to look at then is exactly what the effect size is. So if you're in a psychology class, there's a lot of times that you're looking at like a Cohen's d, where you're trying to say what is the effect size, as opposed to just looking at your p-value. And for us, a lot of the times, we're just looking and saying, oh yes, it looks like it's increased, but we want to show it's increased by an amount that we care about. So that's the idea of practical versus statistical significance. And the only thing you want to keep in mind here is just look at your p versus your p hat and sort of compare them. If we're talking about like a 63% versus a 64%, do we care? And so I sometimes write multiple choice questions that sort of get at this idea.